Good afternoon, everybody. Today is Monday, August 22nd, 2022, and we're back with another Elixir Exercism track. In the last episode, we worked on docs and type specs. Today, I believe we're going to do case and charlist, and then work on the German Sysadmin example. So we'll get right into this today. So case. Case is a control flow structure that allows us to compare a given value against many patterns. Clauses in a case expression are evaluated from top to bottom until a match is found. So in this example here, we've got age being a value of 15, and we'll run case against that. And so it'll just try to match each case statement. So 0, age when age is less than 4, age when age is less than 13, less than 8, and so forth. And then at the bottom, we use the underscore capture, which basically will capture everything. So that's kind of like the default for that. And then next up is charlist. So a charlist or character list are created using single quotes. So in this example, we've got a single quote, HELLO, another single quote, although they look similar to strings, the two data types are very different, quite different from one another. The charlist is a list of integers. The integers represent the Unicode values of a given character, also known as a code point. So in this example here, if you create a charlist, you can create a charlist by creating a list of integers, and it'll render as the visual representation of those characters. You can prepend a character with question mark to get its code point. In this example, they're getting the code point for the colon character and the right parenthesis character, and then a charlist of that. Because charlists are lists, you can work with them just like you would any other list, using recursion, pattern matching into head and tail. In this example, we'll get the first letter of the charlist cat, and that'll be 99 because that is the integer representation of that character. You can concatenate two lists using high exclamation point. The longer the first list is, the slower the concatenation, so avoid repeatedly appending two lists as of an arbitrary length because that is just slow. They link to the Getting Started guide for charlist, and this is actually quite helpful, this document. So this goes over the high-level concepts of binaries and encoding and UTF-8 within Elixir. So they break down kind of like what we mean when we talk about Unicode and code points, what we mean about UTF-8 encoding, and then bit strings, binaries, and charlists. Highly recommend you read this. It's particularly informative. One of the things I loved when I was learning about this recently was, so like you have this concept called a code point, and a code point, here's let me let's say besides defining characters, UTF-8 also provides a notion of a graph memes. I don't know if I'm pronouncing that right. They consist of multiple characters that are often perceived as one. For example, the woman firefighter emoji is represented as the combination of three characters: the woman emoji, a hidden zero width joiner, and the fire emoji. And they give you this little example which you can run in an IEX session. And I just think it's really cool just to see that in action, understanding like what the difference between a code point and a graph memes. Graph memes is anyway. So that's cool. And so with those two concepts, we're going to get started on the German sysadmin example. You are working as a system administrator for a big company in Munich, Germany. One of the responsibilities is managing email accounts. You have been hearing complaints from people saying they are unable to write emails to Mr. Mueller with the umlaut over a U. You quickly realize that most of the company uses an old email client, doesn't recognize Mueller at firma.de as a valid email just because of their non-Latin characters. Non-Latin character. Telling people to give up their old favorite email client is a lost battle, so you decide to create a sanitized alias for all email accounts. Cool. All right, well, we're going to get started with this locally. I'm going to bring up iTerm 2 can display images, even animated GIFs inline. Oh, I do want to learn more about that because I love me some animated images. But we'll do that afterwards. For now, we will change directory into exercise and we will open it in VS Code. And like before, we'll open the username. Actually, I'm going to make this a little bit bigger. Yeah, that should be good. And then I'll open up the test. And then I'll open up the README. And no. I want to put that down. Put the README down here. I don't want the test helper. I want the file. All right, cool. So we just got one sanitize. Alrighty. So let's go through step 1. Sanitize existing usernames by removing everything but lowercase letters. Implement sanitize function. It should accept a username as a charlist and return the username with all characters but the lowercase letters. For example, Schmidt 1985 should just return Schmidt. Okay. Return all but used. We haven't really learned. Let's see here. Let's see. Char. Well, you can use anything because charlist is just list. You can use anything the list has. So, let's see. Delete. First flatten. No, we don't want. Fold either. Proper insert. I remember sort. Update at? No. Zip. We could solve this with recursion. Considering we did learn recursion. We haven't learned enums yet. Like, so if we go back to the syllabus, I don't believe we've done the enum here. Have we done enum? No, enum's down here. So I don't want to use enum for this solution, although that is handle it in a normal thing. Instead, we'll use recursion. So we'll do a thing where because the username is a charlist, we can handle it just like before. So when we call sanitize, we'll get we'll just call it head and tail. And so eventually we're going to do a case, because we're going to do case and we'll say, given the head character, what do you want to do? And then we'll check, is the implement it should accept a username as charlist and return a username with all characters but lowercase letters removed. So we want to validate, we only want but lowercase. So we only want lowercase things. Have we gotten away? Have we learned range yet? This is kind of the curious thing, because I'm like, how do I get a list of the, how do I check if something's a lowercase or not? But this is kind of one of the fun things of working on these solutions, because it's like normally I might, solve it with a different tool, but I'm trying to limit myself to what we have here. I can't do I could do it with greater than or less than, because that is what we learned in the lesson. So when we learned charlist, we learned that each character is an integer. So we could do like a greater than or less than thing. Um, like, so in this case example, they did this like when age is this, when age is less than that. So we could do that, knowing that lowercase a and lowercase z are kind of like in that same when head is greater than lowercase a, head, or no, you could do it when with an and head is greater than or equal to. We probably want. And if you're looking, I am using the type setting feature where it combines elements, which is why when I do greater than equals, it turns it into that combination character. People like that, people don't. But okay, this looks good. So when this is the case, we want to maintain it. Like I'll just say maintain, or I'll just say keep the char. And if it's not here, we'll drop the char. Don't you? Oh, we're not doing it. All right. So how do we want to maintain it? If we're using recursion, I mean, we could use an accumulator, but I don't think we want to do that because it's \1. I think we would just do the concatenation because we learned about that too. So if you have a char list and another char list, you can use plus plus. So we can do return head plus plus, although that's a char. We'll try this. Sanitize tail. Right? Is that what we want? I think we might need to put this in the brackets. Otherwise, we'll just return sanitize tail. Alright. So the char list comes in, and we break it up into head and tail. So head will be the individual char character, and tail will be the char list of the remaining. We'll look at it if it is greater than lowercase a and less than or equal to lowercase z. We'll keep it, and so we'll just return head plus the result of sanitize tail, and then otherwise we'll return sanitize tail. Now the only other thing we need to do here is we implement the empty list variant. Define sanitize, and we'll match an empty list. Well, an empty list will return an empty list, but if there's a head and the tail is empty, we need to return. Let's run the test and see what fails. We haven't run the test yet. I want to run all the tests on file just because there's only one describe block. And just see what's going on here. So sanitize works. Implemented management. See, they haven't. it's unfortunate because the tests don't align with the numbers. So normally we would accomplish number one and we'd run the describe block for number one. So allow underscores, extend sanitize function. All right, so is this working, I guess, is the question. We have a test that just does numbers. I'm going to add another test because I want to see if we've solved number one. And I want to use the exact. So I expect Schmidt to return Schmidt, and we'll run test at cursor. Test at cursor. So that works. All right, well that's good. Allow underscores. So okay. Do test two. Wasn't expecting to be writing allow test, but that's fine. So we'll put Mark Fisher $, money, and that should return Mark Fisher. So now we'll test number two. Test a cursor. It fails because we're not handling. We could do an or. But at that point, it's like it's getting really. So here, we'll do it first with it as a when is that or head equals underscore. In that case, I don't like that because it doesn't read very well. Guard or is not. You don't have to do this as a guard, so let's implement a private function that basically says, is char allowed, and this will take a single char, and this will return the result of this. So char. Then you can say no, you just do this. Is char allowed head. You can say true. Although this feels like not in the spirit of what they're asking, how they're asking us to solve it. They want us to solve it. What don't you like? Yeah, that should be allowed. Equals. Did that work? Oh no, I need to test it as a underscore. Okay, all right, that failed. That passes. Let's keep moving. We may have to come back. There are 4 non-Latin characters in the German alphabet, and all of them have commonly recognized Latin substitutes. A, E, O, E, U, E. Extend sanitize function. It should substitute German characters according to the table. You can satisfy all usernames already in case. So test number 3. Well, I feel like they have a good test for that, right? Yeah, they already got this one. It substitutes German. So let's do this. Define P. We'll just call this subs. Substitute for German letters. So what this is going to do is this is going to take in a char and then a case so this will take in the char, and when char equals, and then we'll build the little substitution. So when charge is equal to a, it'll return a, or it'll return. Does it have to be? It'll be a list to a list. Let's keep this going. I'm not sure. This is OE. Char when char is equal, because I'm special. The way I do that is well, question mark is normal. For me, I'm on Macintosh. You hold down the Alt or Option key, and you hit U, and that'll come up with the two dots, and then you type U again. You'll get a full character. A2, so do like A, get the other one. I don't write a lot of accented characters, so there's probably tighter ways to. You can't do it that way. And then char when char when char equals the beta symbol. I'm just gonna copy it. And then we'll return SS. And then we need a catch-all for anything. Just return the char. Now the challenge here is that I think what we want is want that in a list, because this is always gonna be a list. Is it allowed? That should be fine. Trying to think of the order that this should be accomplished in. Because we have to do the substitution before we do the sanity check. But then it's weird because we'll get back double. Keeps underscore. Extend sanitize function, it should not remove underscores. Substitute German character for non-Latin characters. Extend sanitize function, it should substitute German characters according to the table. You can safely assume all users are already. But given that, and you'd probably, like, I mean, one way to solve this would be to create two distinct functions. Like the first one does all the substitutions, and then the second one does the sanitizer. But I feel like they probably want us to solve this function. Like, optimized, like not so we don't have to go through this twice. Uh, I mean, one way to do this maybe is we could do when clauses on the sanitize. So that would look something like this. So like define sanitize, and then we'll say head, tail, like we normally do. But then we'll say when, head equals umlaut A. Just do, yeah. Umlaut A, do, that'll just return. Uh, E. I think that's pretty. So then when that's umlaut O, return OE, and that is U, return UE, when this beta is S. Otherwise it would be char. So if sanitize gets called with an empty list, it just if the list has items, then it uses the pattern matching to break it into head and tail. If it's like one character, the first character would be head, tail would be an empty list, so that's fine. And then it does the special language changes. And then is case allowed? Is char allowed? True. Not. I mean, this feels like a poor use of case. I don't know. Let's run the test. I feel like the analyzer is going to use us when we do this. So let's just get it up there. Exercism, submit, lib username, and let's see what the analyzer has to say. Yeah, analyzer's not happy. Elixir has specific naming conventions which include how to name functions that return a boolean char allowed. Is char allowed? Oh. Elixir has a specific naming convention which includes how to name functions that return a boolean. This is the expected name. This is the current name. You're not allowed to say is. Note that guards some built-in functions. Note that guards some built-in functions and macros that return booleans and are valid guards follow another convention. Those and are named with an is prefix. Both conventions. Interesting. So they're saying if it was a guard, I could use the word is underscore, but in a function name, not recommended. Type checks and other Boolean checks that are allowed in guard statement. Interesting. Okay. So we shouldn't use that. Is that the only thing that's complained about? I don't think. Something else. Yeah, using item plus plus list, and so that is longer and less intention revealing perpending. Okay. So instead of the plus plus, they just want us to create the list with the the head tail format. Okay. All right. So something like that. Solve for these. Okay. Okay. Char allowed. Yeah, we'll say. Let's rerun the test. Failure. Oh, we can't do the bracket. Not where that can only be one item. Um, okay, so let's reverse that. Char, char. I think because we know char at this moment is a single, we can be more. Then we can. Let's run the test. Let's upload it. So it says looks good. It passed. No auto suggestions. I feel like I want to rewrite this because I mean the whole goal of this exercise is to use case, and we're not using case. I mean we're doing something where like this could be case. I feel. Yeah, let's rewrite. Um, so because this is like pattern matched. I think what we can do is we'll do the case statements like here. So head, when, and then we'll copy that. And this will return something. So this will return, that'll return tail, and then head, when, two wins. That'll return second. Head, when, and that one. Head, when, doing two wins. That'll return that. And then away. So now sanitize. Sanitize if it matches an empty list. It'll match that. Otherwise, it'll do that. It'll take case. It'll put the value of head, and then it'll just run these case statements against head. So if this matches, do this. If this matches. And then do that. I find out inside a match. Okay. So let's just start this. Like when head equals underscore, we'll just allow it. So that'll just return. Head, no, head and sanitize. So when underscore matches, we'll just do that. We could put this there. I'll put it there. And then this other one will just be head when chart is head. Okay. So we're pattern matching for, we're looking for underscore, we'll always allow that and we'll just have a pass through. We're looking for the special umlaut characters, we'll do our substitutions for those. Otherwise, we'll validate that it's greater than A, it's less than Z. We'll include that. Because it's a single character, we can use this style. Otherwise, we use the plus plus style. And then if none of that matches, then we just call sanitized tail because we're going to drop. Looks good. Run the test. Tests look good. Let's submit it. And we should have iteration 3. Iteration 3 passed. All right, cool. I think this is a more appropriate solution for this exercise, this learning exercise, which of course is asking us to use those tools. Cool. Let us take a quick peek at the community solutions and see what they are up to. Head X when, yeah, that reads better. Sanitized equals sanitized plus sanitized. Yeah, I mean that reads pretty clean. Ours is definitely a little bit more verbose, a little bit more chunky. I like that. I'm not gonna change mine, but I like it. Yeah, this one used enum, which I don't want to use. This one is good. I like this. The fact that they defined a def guard. That seems nice. Is lowercase, take the code point, score. But they used like filter. This is how I would solve it normally. And they're using, substitute, so they're using case there. I mean, I like the solution. It's just using parts of the language we haven't technically. Cool. All right. I think we're good to go. So I'm going to mark this complete. I'm going to publish my solution. And we have learned case and charlist. We have unlocked bit strings and tail call recursion. Talked about earlier. Oh, and then we've unlocked DNA encoding, which is classic historical exercise. Cool. This was this took a little bit longer, but I thought it was more fun. Hopefully, you got to see how kind of work through the problem set. That's it for today. I want to thank you all for watching. If you have any questions, definitely let me know. And I will see you next time. Bye-bye.